we'll look at an example of multiple if else. So this is good one when we want to evaluate of the student grades. Okay, so let's say, for example, student getting 90% should get an A, right? If score, right? So I'm going to prompt the user to enter the score. Let's talk about double score, right? Equals to, let's use the option pane, which we're going to do double dot parse double and prompt the user to show input dialog, right? And say enter scores, right? Now we prompt the user to get a score, convert it to double. And now we have to evaluate this, right? We want to see 90% and up is A, 80 to 89 is B, 7 to 79 is C, right? So if score greater than equals, right, 90, this is an A, we're going to print A. If true is A, right? So we're going to say system.out.print A. Now we'll do else if, you see that we can put another expression, score is greater than equals to 80. 80 is going to be B. Now let's take a look at this real quick. What happens if I get 80 at this point? It will never reach this because it's going to be false, right? Because that's the false statement. 80 not greater than equals 90. Then it's going to check the second one, which is 80 is here. So it's going to print B. And then it will never do another else, right? But if it happens to be 70, then it's just going to fail into this case, right? It will never fail this case, never fail into this case, but it's going to do this case. And it's going to be C, correct? Now let's think about this. What happens if it's 100? 100 is going to fail in this case, right? Which is greater than 90. That's going to print an A. It will never check this, even it's greater than 80, right? Because it's done this, it will never do else again. It's just exit. Make sense? So this is an example of using multiple if-else statements, right? To evaluate student score here. This is going to be D. Else if score less than 60, we can do that too. Then it's going to be F, right? You can stop like that, or you can do another else, right? Else that means when it's something else, which it will never reach that because this cover everything. It is cover everything. So unless you want to use the logic expressions and operators, and is when you put two ampersands, greater than equals 90 and less than 100, less than equals to 100, right? So we want to cover that the score should not be over than 100, right? So that means you can put two conditions in it here, right? And like score greater than equal to 0, and so we never take the negative scores, right? So this and combining more than two conditions two expressions. Just like this is true, and this is true. True and true becomes true, right? But if one is false, then it's become false. Never do this, right? If one is false, then it's going to get to else. Like if it happen to be negative, it will never fail into this. Then it's going to fail to else. And it's going to do this. Even negative 1 is less than 60 is true here, but it's false here. 1 is false, the whole statement becomes false. Because that's AND, right? Logic, right? Like Boolean algebra, or we call Boolean logic, right? Then we're going to say invalid score. Because could be we don't allow negative or more than 100. So that is an application of multiple if else. So let's run this application. And the score 100. No, 10 is F. I just missing 10. 100. A now. Invalid score. Actually, yes, you're right. I never changed this. C and D. Right. And that's the bad part about copy and paste. 56, no, let's say 560. Ooh. It should not say B, right? So something not right. Let's test again. 560. 560 is greater than or equals to 90. Oh. But which that's why it's never fell into these scenarios, but it happened to fall into these scenarios. That's why I say B. See that? We have to take care of this scenario too. That's why you have to keep testing. Then you have to do AND score less than 90. That's another way. Another way we can do, just do the nested if, right? Nested if in front. When it's greater than 100, we check. That's another way to do, or we can just do AND. So that's why sometimes we can do the AND to substitute with nested if, right? Like when we do authentication, we can actually do AND, right? Like if you look back to our authentication program, right? Let's test this first. So 590 should be invalid score now. So let's look back to our authentication program, right? Nested if. So if you use AND, you can actually, but you have to prompt the password right away. After you have show input here, you have to show password, right? So let me just modify this for you. So we're going to create another class and talk about the logic AND operator here. Authentication. So we can prompt the user for login, right, and input for password. And instead of using nested if else here, we can actually use, since we know that we can do AND operators, so we can just do AND right here. The only time that we're going to say hello, right, to username is when both of them are correct, username and password. But you have to prompt it, right, twice right there. And then else just fail authentication. So that should work the same as substitute to nested if else, but you have to prompt it twice. So that's the difference. So it depends on how you want the program to look. Then it works the same here, right? So, but it cannot evaluate username right away. So that's pretty much the problem. If you want to evaluate username right away, don't have to evaluate password when username is incorrect, then you have to use nested if else instead. Like that. Now you just learn the operation and. They also have an operation called OR and NOT. Like, let me just write down here. We have AND. This is like AND, right? And this is OR. Okay, to become pipes, right? OR. And NOT is exclamation mark. Okay. And we have XOR too. The caret is for XOR. And you should know the truth table for this, right? And truth table is what? True, and true is true, right? And the rest is going to be false. If one of this is false, then it's going to make the whole statements to be false. So pretty much this is what you have learned in your algebra. And OR, when we talk about OR, false or, let's just use this, okay. So false or false is false. And the rest is going to be true. So that's the truth table. Okay. Not pretty much just the opposite, right? So not true is going to be, false. Not false is going to be true, right? Now XOR, when it's the same, it's going to be false. Like 2 XOR 2 is going to be false. And when it's different, it's going to be true. So it's going to be like that. And these are the operators for that. And that means you can start to combine more than one expressions. So let's look at an example of how to use logic operator here. Like for example, if true, what you do and, right? True. Then you're going to say true. True. Alright, so let's run this. When it's true, it's going to do true, right? But if one is false, it will, like just what we just said here. Once false, it's going to be false. It will never print out the word true, right? Or you can do replace and with or, right? Like in this case, it's going to make it true, because for or, both of them has to be false. It's going to be false, right? Here, right? 2 or false, it's going to be 2. That's going to print 2 true, right? Like that. Now let's test with not. When it's not false, it's going to be true then. That's going to print the word true, right? See, that's not. Let's test with XOR. So false, XOR false. So when it's the same, it's going to be false. Then it will never print true. So empty. But if one is true, it's going to be true for XOR, then it's going to print the word true.